Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidity of phenol can be increased by introducing electron-withdrawing groups onto the benzene ring, which stabilize the phenoxide ion, conjugate base, through delocalization or inductive effects. Nitration, introducing NO2 groups, is a classic example, but here we consider sulfonation. Concentrated H2SO4 can sulfonate the phenol ring, introducing a SO3H group. The sulfonic acid group, SO3H, is a strong electron-withdrawing group that stabilizes the phenoxide anion by withdrawing electron density from the ring, thereby increasing the acidity of phenol. Reasoning: concentrated H2SO4 reacts with phenol via electrophilic aromatic substitution, sulfonation, to introduce SO3H groups, electron-withdrawing, onto the ring. This destabilizes the neutral phenol less than it stabilizes the phenoxide anion, effectively increasing the overall acidity of the compound. The resulting sulfophenol is more acidic than phenol itself. Why other options fail? A. DIL. H2SO4, to dilute to carry out sulfonation, it does not introduce electron-withdrawing substituents onto the ring. B. DIL. HCl, a dilute acid that does not react with the phenol ring to introduce electron-withdrawing groups, no significant change in acidity. D. Contr. CH3CoO, acetic acid, is a weak acid and does not perform electrophilic aromatic substitution on phenol under normal conditions to introduce electron-withdrawing groups. It would not increase the acidity of phenol. Therefore, the correct answer is C. Therefore, the correct answer is option C.